So solve this combination series parallel circuit. There's no new rules that you have to master. It's simply applying the rules that you've already been working on in series and parallel circuits. Once you make one change in the circuit, I recommend redrawing it so that way you can keep track of every step that you've done. So the 30 and 40 ohm resistor are in what configuration? Series. So the first step, we can add those two together. Redraw my circuit. We didn't do nothing to the 60 ohm resistor, so we just place it back.
You did it entirely.
Huh?
Sorry.
No, this is the way. If you redraw each step, when you work your way backward, it makes it pretty efficient. So we added the 30 plus the 40 ohm resistor to get the 70 ohms, because that's how we add them. RT equals R1 plus R2 in a series circuit. Now you have these two resistors, and these two resistors are in parallel. So next step, we're going to add those together to make this picture. I'm just going to redraw the 50 ohm resistor because we didn't do nothing to it. And we're going to simplify for adding those two. Remember your formula for adding resistors in parallel that you use. RT equals 1 divided by 1 over resistor 1 plus 1 over resistor 2. So 1 over 70 plus 1 over 60. And what do we end up with as a decimal? One divided by 70 equals, as a decimal, 0.014. And that's rounded if we kept going out. And then now we have 1 over 60. 1 divided by 60 equals 0.01 rounded 7, because it's 0.0166666 forever, so we rounded it to the thousandth. 0.014 plus 0.017 equals 0.031. 1 divided by 0.031 equals 32.258. So now this new resistance total is 32.258. And that's adding the 70 ohm resistor and the 60 ohm resistor, 32.258. Now our voltage supplied never changed. So now we're left with what type of a circuit? For these two. Series circuit. And same way you added this, R1 plus R2 equals RT. 32 plus 258 plus 50 is 82. So we're going to redraw our circuit again. So we end up with 82.258. And what is that? That's my resistance total of my entire circuit. We're going to find all of our totals. Voltage supplied to the circuit, 120, comes over. To find I, going back to the charts, E divided by R equals I. 120 over 82.258 equals So the total current 1.459. That's rounded. To find your wattage total, I'm just going to put another formula right here. P equals I times E. I 1.459 times 120. We end up with a wattage total of 175.08. So now you've taken your series parallel combination circuit, you took one step, simplified, added the 30 and 40, got to the 70. Then you added the 60 and 70 because they're in parallel. We redrew it up, we came up with 32,258. We added the 32,258 plus the 50, we got the 82,258, and then we solved for all of our totals. Now, it's time to work our way backwards and solve for all of the variables. So, does anyone remember what is constant in a series circuit? Series circuit. The current, right? So we could take the 1.459, R-E-I-P, and we put it at both spots because the current's the same throughout. Ohm's law, E equals I times R. So to find it, 1.459 times 32.258. 1.459 times 32.258. And we end up with 47.064. P equals I times Z. 1.459 times 47.064. 1.459 times 47.064, and we end up with 68.666. Okay, any questions on how we solve for those variables at this resistor? Okay, with no questions, we're going to keep going. We have to find E. E equals I times R. 1.459 times 50. 1.459 times 50, 72.95, and P equals I times Z. 1.459 times 72.95. $106.434. Now, we can start by checking our work. So we know that the voltage drop of these two resistors needs to equal the source or be really close. So 72.95 plus 47.064, 72.95 plus 47.064. I got 120.014, so it's off by 14 thousandths of 1 volt. Because we rounded, that's probably why we got the 14 thousandths of rounding there. Now, we can check the wattage. Make sure everything else is going good. 106.434 plus 68.666 should end up to 175.08. 106.434 plus 68.666, 175.1, so it's off by 0.02 of a watt. Pretty good. Now, this was our second picture. The 50s values are these 50s values, so you can plug them in. Nothing changed there. 72.95, 1.459, 106.434. That's done. Now, you got to solve for the 60 and 70 ohm resistor. If the 32.258 ohm resistor represents those two, and those two are in parallel, what's constant in the parallel circuits? The voltage. So you take that 47.064 and you put it right here. 47.064. 47.064. Now you find I and P. So E, I'm going to write it, I thought I wrote this up here somewhere. There it is right here. E divided by R is I. So 47.064 divided by R of 70 will give us our current. And we end up with a current of 0.672. P equals I times E. 0.672 times 47.064. 0.672 times 47.064. We end up with 31.627. And we're going to do the same thing right here. 47.064 divided by 60. 47.064 divided by 60. And I got 0.784, and that's rounded. And P equals I times E. So 0.784 times 47.064. 0.784 times 47.064. And we end up with 36.898. And that's rounded also. So you could check your work at this location also. Add up your watts. 106.434 plus 31.627 plus 36.898 should add up to the 175.08. So let's check our work to make sure we got every square going right. I got 174.959. So we're off by less than 1 whole watt. So that seems pretty accurate. And we could add this currents. 0.672 plus 0.784 should come up to 1.459. So let's check our work. 0.672 plus 0.784. 1.456, 3/1000ths of 1 amp. Pretty doggone accurate. Plus we've got a little rounding errors. Well, this 50 is this 50. This 60 is this 60. We could take our numbers up. 72.95. That's the voltage there. 1.459. There's our current. 106.434. That's our wattage. E comes up 47.064, 0.784, 36.898, 36.898. So now, before we solve for our final or our first diagram, questions to get to this point and how we moved our numbers up and around. All right. This 70 ohm resistor represents that 30 and 40 ohm resistor. Those are in what configuration? Series. And what's constant in the series circuit? Amps. So 0.672, or current measured in amps, you drop it here. 0.672. 0.672. Now we just got to find E and P for both of those. E equals I times R. So I'm going to write it right up here. 0.672 times 30 equals 20.16. P equals I times E. So we got 20.16 times 0.672. 20.16 times 0.672. We end up with 13.548. And that's rounded because it was 0.5475. Do the same thing here. 0.672 times 40. 0.672 times 40. We end up with 26.88. 0.672 times 26.88. And we end up with 18.063. And now we can check our work again. Add up your wattages, and it should come up to the 31.627. Let's check it. 13.548 plus 18.063 equals 31.611. And we had originally 627, so we're off by 16 thousandths of 1 watt. You could add up your volts. 20.16 plus 26.88 should add up to 47,064. 20.16 plus 26.88, we end up with 47.04, so we're off by 24 thousandths of 1 volt. We have a little bit of rounding errors, but we are very, very close. So what questions do we have about taking a combination series parallel circuit, interpreting it, breaking it down into each individual step, solving for all of the variables, and working our way backwards?
So you use both maths in one because of the way that series and parallel.
Yep.
That's
Yep.
what I was doing wrong.
So
It's one math. Both.
oh no, it's you have the 3 rules for series, and then you have 3 rules for parallel. And then when you have a combination circuit, there's no new rules. You just have to apply which rule is accurate for what you're going to be doing. So your interpretation of the circuit, it's vital. This helps a lot when you start thinking about how motor controls work. So when you see things in series and in parallel, so like using the timer to disable the memory circuit. Okay, that is in series with either the memory circuit or the coil. Your start and your jog button, those are both in parallel because you could push either button to energize your output. So when you're looking at Ohm's law, it's really helpful to be able to take these connections and then apply it towards like a motor control circuit.
How did you get the number 82.258 from?
Which one?
Okay, on the bottom, right here, yep,
Oh, right here?
yes,
32.258 plus 50
okay.
because those two are in series with each other. So fantastic question. And if any other questions on setting them up, if you've got your formulas memorized and those 3 rules for series, 3 rules for parallel, it will absolutely make your life a lot easier. So any last questions before we do another one?
That was adding or subtracting?
Adding.
Adding them?
Yep. So you take 30, because this would be, so this is adding resistors in parallel. And then for series, it's RT equals R1 plus R2 plus R3 ... And this would be series. So parallel, I would use that formula. And then series, I would use this formula for adding resistors.
To check your work for the voltage at the end, because the 30 and the 40 are parallel with 60, you just take the voltage from the
One of those branches. Because once this is the same, or these two are the same because you combined them over here.
Right.
But you can check your work, add that one and that one should come up to that one. And then it's just like same thing. You can't do the current on add those two and come up because it's series circuit. But you could add these two together and it's going to match up with this one. Or the other side because it's the same. So more questions. Okay, I'm going to shut this one off.